Here we have a precalculus problem. That is, we have to solve the given logarithmic equation for x. Okay, now let me read the logarithmic equation once. Log base 4 of x positive log base 4 of x into 6 equals to 2. Okay, here we have two logarithm addition with the same base, that is base 4. Whenever we add two logarithms with the same base, what we can do is we can take logarithm once with the base, what we have for the given two logarithms, and we have to multiply the two arguments, that is x and x negative 6. Then I'm getting x times x negative 6 equals to 2. Okay, in my next step, what I have to do is I have to convert this equation to exponential form. Actually, this is a logarithmic equation because this equation contains logarithm. To solve for x, I have to convert this equation to exponential form. Okay, how do I have to convert this equation to exponential form? For that, we have to consider the logarithm along with its base over here. So here we have a log base 4. So we have to move this log base 4 to the other side of the equation. When I move this log base 4 to the other side of the equation, we have to ignore this logarithm. We have to consider only the base 4 on the other side. The value which already exists on the other side will become the exponent of this base 4. That is, we have 4 square. And now we have to write this stuff as it is on the left side. Then I'm getting x times x negative 6. Okay, now what we have to do is we have to distribute this x to this x and negative 6. So when I distribute this x to this x, I'm getting x squared. When I distribute this x to negative 6, I'm getting negative 6x equals to the evaluation of 4 square is 16. Okay, here we have a quadratic equation. So to get this quadratic equation in standard form, that is x squared positive bx positive c equals to 0. Standard form means we have to get everything on one side of the equation. On the other side, we must have 0. Okay, now let me make the right side 0. For that, we have to get rid of this 16. So for that, I have to subtract 16 from both sides. When I subtract 16 from both sides, the positive 16 and negative 16 will cancel out. I am getting x squared negative 6x negative 16 equals to 0. Okay, now I got the quadratic equation in standard form. Okay, now I think this quadratic equation can be solved by factoring. For that, we have to multiply the constant term negative 16 by the coefficient of x squared. In this case, it's 1. When I multiply this negative 16 by the coefficient of x squared 1, still I'm getting negative 16. Okay, now I have to get two factors for this negative 16, so that the sum of the two factors I'm going to write over here must be equal to the coefficient of x, that is negative 6. So I think negative 8 and positive 2 will work, because when I multiply negative 8 and positive 2, I'm getting negative 16. When I add negative 8 and positive 2, I'm getting the negative 6, which is the coefficient of x. Okay, further, I have to divide both these factors by the coefficient of x squared 1. Even if I divide this negative 8 and positive 2 by 1, still I'm getting negative 8 and positive 2. Okay, now we have to get two values for x from these two factors. How? So to get the first value of x, I have to change the sign of the first factor, negative 8. So that is, it's negative. So when I change its sign, it will be positive 8. So x equals 8 is the first value of x. Okay, now let's get the second value of x. For that, we have to change the sign of the second factor. It's already positive. If I change the sign, it will be negative 2. So now I got the two values of x. I have solved the given logarithmic equation and I got two values of x, 8 and negative 2. And so we may think we got two values. Can I say that both the values I got over here are correct? No, I cannot say both the values are correct. So whenever we solve logarithmic equation, once we get the value of the variable, always we have to check the values with the given logarithmic equation. So here x is being as the argument of the logarithm. Here x negative 6 is being as the argument of the logarithm. So the argument of the logarithm can never be a negative value. It cannot even be 0. Always it has to be greater than 0. That is the argument of the first logarithm x has to be greater than 0. The argument of the second logarithm x negative 6 has to be 0. So now if I take 8 as a value of x, so and if I plug in over here, so the argument of the first logarithm is positive. If I plug in 8 over here, that is, I'm getting 8 negative 6. 8 negative 6 is 2. So when I take x is equal to 8, the second argument, the argument of the second logarithm is also positive. So the first value of x, that is x equals to 8, works with both the logarithms in the given equation. So we can accept the first one as solution. Okay, what about the second one, x equals to negative 2? So when I plug in x equals to negative 2 into the first logarithm, so what will happen? So the argument becomes negative. So we cannot accept that, since the second value of x, that is x equals to negative 2, makes the argument of the first logarithm negative. You don't have to verify with the second one. Even this value of x does not satisfy the first logarithm. So we can reject this one. So therefore, the solution for the given logarithmic equation is x equals to 8.